Hello, I'm Jay Buckley, Technical Training Manager at Honeywell Consumer Products Group. Welcome to Module 6 of the Autolite Challenge Professional Technician Program. This module explains how to begin troubleshooting engine misfire codes. We'll cover what the term misfire means, why it's important to understand, and how to begin your troubleshooting routine. Maintaining a healthy ignition and fuel system is important to preventing misfires. A misfire is defined as the lack of or loss of combustion in a cylinder. When an ignition misfire occurs, raw fuel and excess oxygen are dumped into the exhaust system and catalytic converter. The converter runs very hot, causing the fuel to burn inside the converter rather than in the combustion chamber. The converter temperature can rise to a dangerous level and elevate hydrocarbon emissions output. The situation goes downhill from there. The oxygen sensor will detect excess amounts of unburned fuel in the exhaust. The excess oxygen that was not used during the combustion process results in rapid switching of the O2 sensor and a potential loss of fuel trim control. In the past, it was sometimes assumed that this sequence of events would cause the powertrain control module, or PCM, to increase the fuel injector pulse. This would lead to even more fuel releasing into the exhaust because the PCM determined the system was running lean. In fact, what happens isn't consistent from one firing event to another, let alone from one car to the next. Misfires have many potential causes. They can be caused by worn or malfunctioning ignition system parts like spark plugs, ignition coils, or wires. Misfires can be fuel-related, caused by leaking, restricted, or malfunctioning fuel injectors. Misfires can also be caused by mechanical issues. Low compression, skip timing belts or chains, and worn oil control rings can all cause misfires. With experience, you should be able to feel the difference between a misfire that's related to only one or two cylinders as compared to one that's occurring to most, if not all, the cylinders. Sometimes the cylinders that are misfiring can all be on the same bank on a V engine. You need to recognize when this is occurring, determine what the likely causes are, and consider how this type of misfire will impact your diagnostic routine. There are two types of misfires, Type A and Type B. With a Type A misfire, the check engine light will constantly flash. This type of misfire can potentially damage the catalyst and must be repaired immediately. A flashing check engine light indicates that the vehicle is experiencing a constant misfire. The driver will usually feel this type of misfire as well because the engine will run roughly. Type A misfires will readily count up on the 200 rev counter in scan data. A Type B misfire will set if misfires of at least 2% are detected on the 1000 rev counter. This may cause tailpipe emissions to exceed federal standards by more than 1.5 times. The check engine light will be lit and the car may or may not run poorly. Most misfire detection is based on the assumption that crankshaft rotational velocity varies as each cylinder contributes its power output. When an engine misfires, the crankshaft slows down a little bit. When the OBD2 system detects a high enough rate of this slowdown over 200 engine revolutions, a misfire code may be set. If you have a misfire, the check engine light could be on. Begin misfire troubleshooting by connecting a scan tool to read the codes. OBD2 diagnostic trouble codes, or DTCs, can lead you to whichever cylinder is misfiring. For example, a DTC of P0301 would indicate that cylinder number 1 is not contributing as much as it should, but the DTC will not tell you why it's misfiring. If a misfire is ignition related, the onboard computer will not be able to tell the difference between a fouled spark plug and a grounded plug wire. In this case, you'll have to dig deeper to diagnose the misfire. When diagnosing ignition misfires, it's very important to use tools that allow you to see what's actually going on. A scan tool displaying data generated by the powertrain control module can't tell you what the ignition waveform pattern looks like. It can only show you that the powertrain control module has detected a slowdown on a particular cylinder or on multiple cylinders. A random misfire DTC such as P0300 shows that the misfire is random and moving from cylinder to cylinder, or that multiple cylinders are experiencing a misfire issue. This type of misfire can be caused by a lean condition at idle. It may be caused by a vacuum leak, clogged fuel injectors, or a leaking EGR valve. Once you pull the codes from the powertrain control module, remember to freeze frame and record the engine operating conditions that the system stored when the misfire codes were set. A good diagnostic routine requires attention to every detail. Solving a misfire that is evident right now because of a vacuum leak, but missing that the powertrain control module actually coded for a misfire that was occurring on the highway, could lead to a disappointed customer. If the random misfire code is accompanied by a DTC of P0171, indicating a possible lean cylinder bank 1, or P0174, indicating a possible lean cylinder bank 2, it will help to confirm under what operating conditions the lean engine code set. You may need to see if the lean condition is more prevalent to one side of the engine or the other. Is the other side trending rich while the side with the misfire is going lean? What does it really mean if long-term trims show significant bank-to-bank fuel correction? Do you have a cam out of time or a restricted exhaust on one side? Remember, before proceeding any further, you must find and correct all diagnostic trouble codes by following OE recommended troubleshooting instructions. You'll find these instructions in the OE repair manual for the vehicle you're working on. Sometimes a rough road will cause torque to be applied to the drivetrain, resulting in false misfire codes. Many powertrain control modules will use input from the ABS wheel speed sensors to tell the PCM the vehicle's on a rough road, and then ignore the misfire codes. Ignition-related misfires are very common. Start by measuring secondary voltage and spark duration if possible. In a coil unplugged system, use a low amp current probe to measure the coil's current draw and inspect the on-slope and oscillations at turn-on. Using a low amp current probe can be really helpful when you're dealing with one of today's newer engines, where access to the spark plugs can require a lot of removal and replacement of engine components and covers. Once you remove the spark plug from the cylinder that's misfiring, how does it look? You have to remember, as the spark plug gap opens up from wear, the voltage required to fire the spark plug will also rise. When this rise in required voltage exceeds the coil's maximum output, a misfire can occur. The misfire could be related to weak spark plug boot insulation and carbon tracking. A lean injector can cause secondary voltage demand decline and can lead to breakdown of the insulation and secondary components. You should always use a platinum or iridium fine wire spark plug in modern conventional or coil on plug ignitions. An Autolite double platinum spark plug or an iridium enhanced Autolite XP spark plug should be used in DIS ignitions. While it may seem like a bargain to use a copper core spark plug in a modern ignition system, it really isn't. A copper core plug will experience considerable gap erosion in as little as 18 to 30,000 miles. When the gap opens up to the point where the coil can no longer generate enough voltage to fire it, a misfire occurs. Your customers will not be happy when they find out their original plugs lasted 100,000 miles, and yet the copper core spark plugs you installed only lasted 30,000 miles. Remember, when copper core plugs were common, so was the once a year or 12,000 mile tune-up. Oil fouling can indicate mechanical issues with the engine. Fuel fouling would indicate that the engine is not firing. Test for spark at the plug first with a spark tester, then test output from the coil. A simple spark tester will show if the coil is producing enough voltage to fire a plug in a cylinder. If you have an oscilloscope, hook it up and take a look at the ignition waveforms. Cylinders with very high firing voltage may have worn spark plugs, lean injectors, or bad plug wires. Cylinders with low firing voltages could have a fouled spark plug, carbon tracked insulators and plug boots, or little to no compression in the cylinder. Now, let's talk about how you should investigate a no start. The first step is to check and see if the check engine light is on when you turn on the key. Next, check to see if the theft deterrent light is flashing. Can you hear the fuel pump run for 2 seconds when you first turn the key on, and then again after you start to crank the engine? If everything checks out so far, move on to spark and fuel pressure. If you have spark, do you have fuel pressure? Remember, just because the pump runs and you have pressure, that doesn't mean that the injectors are supplying the fuel to the engine. If you don't have spark, test the coil power supply and test for a good ground circuit. It's best to use an oscilloscope and a low amp current probe. If possible, use a scan tool to command the powertrain control module to fire the ignition coil for testing. If you have spark, then you only need to be concerned with when the spark is occurring, fuel delivery, and the engine's mechanical condition. The goal in diagnostics is to first confirm what's working, then you only need to test what isn't. We can cover more fuel-related and engine mechanical diagnostics in a future series of videos. For now, let's go back and talk about testing for misfires when the engine is running. Begin by checking both the static and running fuel pressure and compare them to published specifications. This is a Autolite. When hooked up in place of the injector, it will tell you if the powertrain control module is sending a signal to fire the injector. Some techs learn the hard way that a Autolite might show you that the computer can try and command an injector to open, but it doesn't show you if there's enough current flowing to command an injector to open and spray fuel. This often results in a misdiagnosis because the tech interprets the Autolite as flashing as a good injector signal. A low amp current probe and an oscilloscope can confirm the circuit works correctly under its own electrical load. The current ramp plus the gull wing on the ramp not only confirm the circuit's ability to command the injector to open, they also indicate that the gull wing is actually the pintle of the injector moving inside the coil. This proves that the injector really did open. Remember, the injector could still be restricted and it may not be supplying enough fuel. More testing will be necessary to prove if that's the case. Keep in mind that many manufacturers today will disable the injector pulse if the powertrain control module detects a misfire. Just because the PCM isn't turning on an injector right now, it does not mean the PCM is defective. Shutting the engine off and then restarting it may result in the powertrain control module firing the injector again until the PCM detects a misfire and turns it back off. There are many potential mechanical causes of misfires. Start by checking engine compression on the offending cylinder. This can be done with a big box analyzer or an oscilloscope and a high amp probe. If these diagnostic tools are not available, start your normal compression testing on just the cylinder that you detected the misfire on. Record the cranking compression reading. Then start the engine, bleed off the pressure in the gauge, and re-record the compression at idle. It should be 50% of the cranking compression. Now raise the engine off of idle to 2500 RPM and bleed the gauge again. The compression should still be very close to 50% of the cranking measurement. If the cranking compression is low and the running compression is higher than 50%, worn piston rings or a leaking valve are likely causes. If the cranking compression is correct, but the running compression is low, you may have weak or broken valve springs. Next, snap the throttle a couple times and allow the gauge to store the high pressure. If this reading is significantly higher than the cranking compression, you could have a restricted exhaust or an exhaust valve that isn't fully opening. If the spark plug is oil fouled, the oil control rings may be worn excessively. The engine will then require internal mechanical repair. These are generalized instructions. Always follow the troubleshooting diagram in the OE service manual for the vehicle you're working on. Congratulations! You've completed the 6th and final training module of the Autolite Challenge Professional Technician Program. Thank you for your time.